We have Sonali here today to talk to us about the AgMIP climate analyses. Really the idea here is to move beyond mechanistic and into the analysis side with a preview of this. And a lot of this will be done at the workshop, where we really want the workshop time to be spent looking over the results of the data, not just how do we turn the crank. So Sonali, over to you.
Sure. So I hope that everybody can hear me, and I'm going to speak a bit slower than I normally do, and I will stop for questions about halfway through as well too. So as Alex said, today is going to be largely focused on analyses, and I have, you see in parentheses in the title, crops there as well too. Engage the crops team a bit more than we have in the past at this next workshop. And we've got a few dedicated sessions for that. In addition, we're going to be talking today about methods and procedures, which I know everyone is probably deeply interested in, sort of how do we implement all of the things that we want to implement, and I'll discuss that a bit briefly as well too.
And then we'll pass to Cheryl at the very end.
Yes, and then Cheryl has a quick presentation to make regarding FACEIT, which is going to be immensely useful to us in the procedures and the methods and the how to do this. So we'll pass that on to her. Okay. So the next two slides are really just a review, and I won't spend too much time on this, as Alex has done a really good job of stepping through this during the last webinar. Suffice it to say that we're looking at the historical climate and future climate change projections on the bottom, but overarching this entire phase 2 design is this big purple box above the, which is supposed to include our new stakeholder unit, which is becoming a really vital part of these teams. And so part of what you'll hear me say throughout this talk is that we're interested in rigorous climate crop analyses, but also engaging the stakeholders to help us identify important sources of variability and important attributes of our climate crop analyses. And also, both for the stakeholders and ourselves, to build confidence in the analyses and studies that we're doing. And so that's going to be sort of a prevailing theme throughout this talk. As you can see on the bottom, Alex has highlighted on the left-hand side the need for quality-controlled historical climate data sets and understanding variability and trends in the historical series. We're also going to be weaving in the CTWN sensitivity component, and we've got a couple of different ways to do that, which I'll talk about. And we have a couple of new applications of future, new ways to create our future climate projections and new applications of those. And so we'll talk about that as well too. And I wanted to quickly review the goals as they're pertinent to the structure of this talk today. And again, Alex has already presented these. The climate team has three main areas of focus, of course not limited to these, but these are going to guide our discussions. The first is looking at the historical period climate data sets. And again, quality controlling a good historical baseline data set will be important. But now we're also going to move into understanding and analyzing that historical period in a way that we didn't have much time to do in phase 1. We'll be looking at the sensitivity of agricultural production to important climatic parameters, and we've also included nitrogen as well too, and I'll talk about that. And we've got, again, as I've been saying, new ways to implement our future climate scenarios. And so this historical period, evaluating sensitivity, and then our future climate period are going to be sort of the three main tasks that we'll focus on. And of course, this is all meant to also engage the crops group. Okay, so I'll start a little bit on the methods and procedures that we'll be using. I'll go through this section slowly, take questions, and then we'll talk a bit about some sample analyses that I'll show to illustrate these methods. So firstly, all regional research teams should have by now the climate scenario generation guidelines and also the R script packages that were distributed in phase 1. if there are new climate people attending this workshop, we are happy to work with them to get them up to speed. And we do hope that anyone who is in phase 1 for climate, right, will distribute and share these R scripts as well too. These are currently being updated as we've got a few new tools and different methods. And so we are intending to distribute these shortly, if not before, then towards the beginning of the workshop. And so please be on the lookout for those, in addition to having your phase 1 R scripts.
And maybe I'll interject there for a second. The updates to the R scripts are not transformational. This is not code that has changed to the point where you have to redo previous work. It's really things like additional bells and whistles, more data, additional climate models for us to potentially look at, things like that, and then some visualization and analysis scripts that we think will be helpful. So it's nothing to worry about, but we can look forward to enhancements coming.
Sure. And so these tools and utilities have been created to help us in quality controlling the historical climate data. So you'll be able to sort of create the AgMIP formatted files, to run and visualize the CTWN and C3MP sensitivity tests that we'll be undertaking, and to produce new future climate scenarios. As Alex said, structurally there's not too much different in terms of the way that you'll implement the scripts. But with these new scripts, we'll have the ability for future climate scenarios to select GCMs sort of tailored to the range of uncertainty and projections at each specific site, and as you'll see also that are seasonally dependent as well. So we'll kind of step through all of these things and what this will look like. I'll start, however, in emphasizing that the most critical step and first step in the climate portion of the work is to really achieve a quality controlled and a representative historical climate series, as this is going to inform the entire project and set up the baseline assessment. And so we want to make sure that not only is it bias corrected, quality controlled, gap filled, all of those good things, but we also want to understand what's happening in the historical period and the sensitivity there. Okay, so in sticking with the historical period for just a minute, most of those procedures have not changed all that much. We had extensively reviewed and gone over gap filling and filling in data that's missing and quality controlling the series. And so we expect that for any new sites, and we know many of you are running additional sites, that the same procedures will be in place, and we're happy to help with that at the workshop or anytime before or after, of course. This is what you're looking at here is a screenshot of this AgMIP Excel file template, and you'll look for version 2.0. After your baseline climate series has been quality controlled and constructed, we'll need to create that .AgMIP file format. And it took us a little bit to get to this point in phase 1, but now that we have this utility, this will expedite the formation of this series quite a bit. So we'll be distributing this Excel file template, and what you'll see in this front page, if you look at the tabs below on the screenshot, you'll see an input data tab sheet and a baseline data sheet. We're currently on the input sheet. After you've constructed your baseline data, you're going to actually copy and paste that data, that daily data, right, into each of the green columns that you see on this file. So the year, the month, and the days don't change. We're looking at daily series from 1980 to 2010. But your solar radiation, Tmax, Tmin, rain will represent what you've done for your sites. And if you have any of the other parameters, those will be input there. You'll see above that the data entry portion. You'll see this green box that says check for correctly entered data. So we do enable you to check that everything is there and that you're not missing anything or something has been incorrectly entered. If you look at the top left-hand side of your screen under the AgMIP logo, you'll see user entered values. So here's where you'll enter your 8-digit file name, latitude, longitude, elevation, all of those things that contribute to the formation of the .agmip file. And then you'll hit that create .agmip file button, which is sort of in the center of that page. And that will produce in your working directory the .agmip file. Now, if we move to the next slide, this is the second tab in that sheet. It says baseline data, and this looks very similar to what you're familiar with in the AgMIP structure. This sheet automatically is populated with whatever you enter on sheet 1. And so this is supposed to streamline your AgMIP file creation, and after you've done the conventional quality controlling, this should help you to produce those AgMIP files in a very simple way. And again, we can help with instruction and distribution of this file, of this template when we're there.
And maybe just to add to that, you know, that the idea here, if Sonali would go back a slide, you know, a lot of people, a lot of agencies across the world have their own format for the way climate data are stored and the daily meteorological data. And oftentimes we get things that are in rows instead of columns or cast around several different sheets. The idea here is to have a template in which you can paste your data in. Those orange boxes that currently say, I think, no will switch to yes when the data is complete in terms of filling in all of the boxes. And this does all of the annoying formatting that we were struggling with in years past in terms of getting the proper number of digits and white space and all those things that the .agmip format needs. And the nice thing about that is then once you have it in this format, it can quickly go into all of the R scripts and the IT tools like FACEIT that Cheryl will discuss later. So this is designed to facilitate the setup of this baseline file.
Right. Okay. And as Alex had mentioned, and I've mentioned before, we're happy to help with either the quality controlling or the use of this sheet. Okay. So moving on, and we're going to have an analysis section shortly where we start to look at some of the things that we're interested in. For now, I'm just walking through some of the procedures. The next procedure that we'll talk about are these CTWN and C3MP sensitivity tests, which is sort of the next section. So CTWN stands for carbon, as in carbon dioxide concentrations, temperature, water or precipitation, and N is nitrogen. And I'll talk about the C3MP acronym in just a minute, although I'm sure most of you are very familiar at this point. But first, the CTWN analyses. So these are needed to understand key responses of our crops and crop models to major climate change and climate variability factors. Okay, so each of the C, T, W, and N constitute a factor, right, of climate change. We expect that these analyses will help us to interpret our results, not just in evaluating sensitivity, but also under future climate change, and could serve as a useful component for calibration as well. And so in evaluating sensitivity, Alex had reviewed this prior, we'll just talk about it for one more minute, are three main tasks. The first is climate variability, largely in the historical period. And so there is where we are going to first engage the crops team quite heavily. We are interested to examine the simulated crop yields from the historical period against the historical climate variability. We expect that in doing this, it's going to enable interaction with stakeholders to identify key climate metrics and major historical climate or weather events. And if we can work together, climate, crops, and stakeholders to do this, we're hoping that this is going to help all of us, stakeholders in particular, to build confidence in applying these models.
And just a point fast, in that historical climate variability, of course, carbon dioxide doesn't change much over a short period of time, and nitrogen in the crop models is fixed throughout all of those periods. So really all we're looking at in that case is temperature and water response.
Right. The second bullet that you'll see here refers now to sort of a specific component of our work, one of two, and this is CTWN, single factor analysis, as you'll also hear it referred to. And here underneath, you'll see each category, carbon dioxide concentration, Tmax, Tmin, rainfall, fertilizer. These are all the factors that we are varying over in a, individually, right, as a single factor analysis. And so you'll see there are 5 carbon dioxide concentration levels. We run in 5 separate simulations. We'll be doing that for 2 levels of nitrogen for a total of 10 simulations there. For changing Tmax and Tmin, we are going to move incrementally from -2, 0, +2, up to 8 degrees Celsius for a total of 6 simulations. And this is separate from the carbon dioxide concentrations, right? So we're testing each of these things individually. Rainfall, then we've got 8 factors that will be varying over there. And then finally our fertilizer amounts, and those are 8 simulations. So this totals to 32 sensitivity tests varying these factors. And we expect that these will allow us to examine the crop and crop model response to direct changes in each of these variables individually, save the carbon dioxide and nitrogen levels. And so that has utility in single factor analysis. If I jump down quickly now to number 3, the CTW uncertainty that we're largely conducting through the lens of C3MP, which is the Coordinated Climate Crop Modeling Project. Here, we are going to be, I'll be explaining this in just a minute, but we're going to be running 99 sensitivity tests that allow us to look not just at the single factor, but also at the interactions between some of these factors, in particular carbon dioxide concentrations, temperature, and rainfall or water. And so we see number 2 and number 3 not as redundant, but as complementing each other into evaluating both the single factors and how each of these factors are important, and then the interaction between these factors. And we've created and are in the process of creating a host of tools and scripts that we expect and we hope will make this very easy to implement so we can get right into analysis. And we're not expecting, and we don't want anyone to be bogged down by these simulations. So we will work together in Victoria Falls. We have at least 1 or 2 sessions currently on the docket right now to look at this stuff. We will work together to visualize and plot multi-model results. So DSAT, AppSim, InfoCrop, any models that you're running, right, that you can perform these tests with. From the 32 linear CTWN tests. So I'm going to skip back a slide just for a minute. This refers to bullet point number 2 here. And importantly, these 32 tests will be applied to a single farm. This is also true for C3MP. Again, we are not looking to burden anyone. We're looking to sort of really delve in and rigorously analyze some of these results and sensitivities. Now, these are specified in updated versions of the protocols, which will eventually be distributed soon. And for the sensitivity tests, we might have a set of instructions or guidelines that we'll be distributing as well too at the workshop. So to accomplish these 32 tests, specifically to visualize the results from these tests, are scripts that are just a plotting package effectively and will help you to efficiently plot your results, will be distributed along with a guide for use. And what we're hoping is that everyone, all the teams, will be able to produce similar plots for these sites so we can basically get everybody's results together and look at them during the workshop and actually dig into some of the analyses. Now, these tools eventually will also be made available through FACEIT, and Cheryl will talk a bit more about that later, and we're hoping that this will just even further enhance how efficiently and rapidly we can perform these experiments. And I should mention at this point, even for C3MP, these sensitivity experiments and all of these sort of development of these tools and methods are going to be an ongoing effort throughout phase 2. And we expect that the regional research teams will want to undertake further analyses, perhaps even modify some of the tools that we've provided, create additional plots, maybe even improve what we've done. And so we hope that this session in Victoria Falls can serve as an initial start to your work and evaluating these sensitivities. And we really encourage interaction with everyone to help make these procedures better and more streamlined. Okay, so we talked a little bit about the single factor CTWN analyses. Now we're moving on to what bullet 3 was, which is talking about C3MP, to examine carbon in that sort of first paragraph, to examine the interactions between carbon dioxide, temperature, and water. Each of the regional research teams will execute 99 C3MP sensitivity tests, again at a single farm. Now, for each test, carbon dioxide, temperature, and water or rainfall will be altered together. And we've created, I'll say right now, a few tools, particularly for DSAT and APSIM with others on the way, to implement this very efficiently. So again, we're not looking for anyone to get bogged down, but we have some pretty rapid ways to do this, and equally rapid ways of plotting, visualizing, and analyzing this, which I'll talk about in just a second. These results, how will they be used? Well, they'll be used then to train a regression emulator, the form of which you can see in that narrow green box below, the basic form of the emulator. And this will allow us to continuously visualize the crop and crop model response to change using impact response surfaces, which I'll show a little bit of in just a minute. And we can evaluate the change in each of these terms as well as the crop terms. So when you look at the last 4 terms on the end of that emulator, you'll see that we're exploring the sensitivities between the terms as well too. The interactions between the terms as well too, and how sensitive our crop and crop models are to this. Now, below that, we'll see the C3MP sensitivity tests. We've just shown 1 through 9 there, so you can see what the combination of these factors look like. And that's what will be implemented over 99 iterations of that. Okay, so each team will run these 99 sensitivity tests. When complete, the teams will load their yield results for now into a reporting template, which we will distribute. And they can submit those templates to either Alex or myself at the workshop. And we can generate the response surfaces, which I'll show in just a minute. We can provide instruction at the workshop on how to use these templates as well too. Again, these are meant to expedite this process. All the protocols, templates, documentation, downloads can be found at our website at agmip.org/C3MP. So if you're feeling intrepid and would like to accomplish these prior to the workshop, I know a few of you are, please feel free to visit that site and or email us, and we can send you everything that you need. And in contributing to the project, it won't be just relegated to the regional research work, but you'll also be part of the greater C3MP initiative and have access to the larger database for those submissions around the world.
And I see Ken had a comment in the chat box about the need not just to explore sensitivity here, but also to understand it and to compare between the crop models, and that's definitely an aim of ours. So some of the tools we've created, for example, allow direct comparisons between response surfaces or these linear response tests that we're going to be looking at. And again, the idea here is not just to create some interesting plots. The idea here is to understand what our system is doing, if it's acting the way we think it should, and if it's not, maybe it needs some kind of calibration or some kind of other adjustment to our understanding.
Okay. So a quick word about the future climate scenario methods. We'll have just some updates to the R scripts that will be circulated, and specific changes to the generation of the future climate scenarios include R scripts that alter mean and variability together, an enhanced delta approach. These were in fact distributed, although they will be updated a bit during phase 1. I think some of you have actually run the mean and variability changes at your site, but we'll be using the mean and variability change first and foremost, whereas phase 1 utilized more the mean change only. We'll be utilizing a GCM selection approach that better captures the range and uncertainty of models climate changes in a site-specific way. So each site we'll still have 5 GCMs, but it will be more of a unique set of GCMs that capture the range of response, climate change rather, at that site. And we intend to include additional GCMs from the CMIP5 archive now and when they become, as they become available as well too. And those are updates that we will circulate. Okay, so this is just to summarize what we're looking at here. Alex had presented that earlier. Everyone should have this guide for running the AgMIP climate scenario generations and tools, and the R scripts. And you should also have in your hands right now, although you'll receive updated versions as well, a metrics generation script as well to look at the annual metrics that you choose, Tmax, Tmin, or mean Tmax, mean Tmin, total rainfall, things like that at each of your sites. And I'll show in just a minute how that can be useful for your applications. Okay. Should we take, does anyone have any questions outstanding as I move on to the analyses?
So just to interject, so Sonali has just laid out kind of the mechanics of it, and these are, you know, the idea of what we're trying to do and the tools that we think are able to get us there. And it's a step forward from where we began phase 1 for those of us who were part of that first project, in the sense that we already have these established scripts. Many of you already know how to use it or how to use them. And we'll talk a little bit about even further how we can make this simple with Cheryl's FACEIT tools as we go forward. But if there's questions about the mechanics of it, why don't we ask now? Or since time is short, maybe we'll just keep going.
Yeah, they're not right now. Yeah, so we'll leave time at the end as well too, but please feel free to put your questions into the chat box. Okay, so now I just wanted to present some sample types of analyses that can be done, first and foremost on the historical climate period.
And somebody just joined, can you please use the microphone? Thank you.
Thank you. Okay, so I'm going to be showing most of this work from the South India team, whom I'm representing as a resource person as well too. So you'll see results here and climate information from Coimbatore, South India. This plot is specifically for rain-fed maize, and what you're looking at here in the box plots are the yields across 60 farms that team has simulated in South India. The line that's imposed on top of the box plots is the total seasonal rainfall. And for rain-fed maize, that season is September, October, November, December. So that corresponds with the northeast monsoon phase there. So the axis for the total rainfall is on the right-hand side. The axis for yield is on the left-hand side. And what you see here looks initially to be a fairly strong degree of correlation, at least initially. But there are a few instances across this period, such as 1997, where we get peaks in rainfall, but perhaps not the associated yields that we might expect. And so what this enables us to do, and I could ask someone to please mute. So what this enables us to do, really, is to understand and contextualize the yield results that we're getting in the historical period against an important climatic parameter. In this case, it's total rainfall. But we could do this, and this was generated using the metric script, that total rainfall. And so we could do this for a host of the climate variables that we were interested in looking at. We encourage also the comparison. Now, these are simulated yields across each of the farms in comparison with the historical climate data. In this case, it was observed. In order to make this kind of assessment and really understand the rainfall, the crop rainfall variability, we do also think that it's important to overplot on this, if available, observations. Yield observations from the field sites. And if we have those and can put that on there and compare that to the simulated yields in comparison with rainfall or whatever other climate metric you have, again, that can help us build confidence in some of these results.
Yeah, and this is something that, you know, we would like to be able to go to the stakeholders and show a plot like this to say, yes, our model is representing something like reality. This is how we're going to build the confidence. We don't expect it to be perfect, of course. There are very few long-term research sites, if any, in our regions that would have, perfectly controlled field data. But even district level yields, might see 1997, 98 kind of as El Nino years and see a signal there that we could say we've maybe captured or not. So this type of information is going to be very helpful as we're trying to build up our confidence in the model.
Right. Now, Alex had mentioned in the previous webinar, and has been mentioning this as well too, we really would like to engage the crop modelers and agroclimatologists in each of these groups to understand how the rules of thumb that are typically applied to climate crop assessments in their region can be applied. So here we're looking at a northeast monsoon onset rule of thumb that's used, at least in the Coimbatore district, which is identified as a 2 to 3 day period after September 15th, in which cumulative rainfall exceeds 25 millimeters. And so what we've done here is to plot how early or delayed, so a negative value would correspond to an early monsoon, a positive value would correspond to a delayed monsoon in this plot. And what we're plotting is the onset, how early or delayed it has been over the 1980 to 2010 time period. So we're moving beyond now just the types of variables that we're used to looking at or that are available through your climate data sets, and actually looking at rules of thumb, in this case onset, a kind of multi-layer definition, right, as we see here, another layer into the climate analysis. That little X that you see there was a year that did not meet this criteria, and so considered a monsoon failure, right? The onset didn't come. And there's quite a bit of variability in this series as well, too, and something interesting to look at. Now, the next plot that I'm showing is are the yields across 60 farms, the rain-fed maize yields for APSIM and DSAT. And I've looked at the correlation here between the historical 1980 to 2010, 2009 yields and the monsoon onset. And actually, I haven't showed another figure, but when we looked at and this is purely a simple correlation analysis, but if we looked at the relationship between any other climate feature, so the number of rainy days or even total rainfall in that sense, we actually wound up having more farms with slightly higher correlations using the monsoon onset rule of thumb than we did for some of the other climate variables. And so this is just a sample of how utilizing some of the definitions that we work with locally or regionally can help us add a layer to the yield, to the climate crop analyses that you see here. So again, moving on, this is an observed series that was bias corrected and quality controlled. And right now you're looking at the same total rainfall that I had shown earlier from 1980 to 2010. Again, this is a great point for a stakeholder to come in and start to look at some of these peaks and valleys, right, and think about what exactly occurred at those times. Can they be attributed to ENSO phases? Can they be attributed to other sources of climate variability? In this case, it would be Indian Ocean sea surface temperatures or Madden-Julian oscillation or whatever sources of variability play out or dominate in the region. It's important to assess that. The other thing that I'll mention here, as this is an observed series, is that there is a significant trend over the historical baseline series in rainfall for this region, an increasing trend, and understanding that that exists, I think, is an important part of the historical assessment as well, too.
Especially as this is a region where projections of the climate model suggest we'll get wetter, so we can show that it may have already started.
Right. Okay. So moving on, I'm going to show just a quick, simple application. We haven't done the CTWN single factor analysis just yet, so I'm going to show the sensitivity, the C3MP, Response surfaces, impacts response surfaces. I think many of you have seen this before in some of Alex's presentations regarding some other samples. I wanted to pull one from one of our sites that were in the AgMIP Regional Integrated Assessment. So again, this is for Coimbatore, South India. What you're looking at is irrigated rice here, and this was submitted by Dr. Geeta Lakshmi Velangiri in the first phase of C3MP. And what you're seeing in the impacts response surfaces, I think, reflects what we'd expect of rice, irrigated rice, at least in the region. If we look at the first plot, we'll see that there's not much of a response to precipitation, in that increasing precipitation doesn't really help much. It is irrigated rice. However, we see sort of the brown values, declining yield values, as we move up incrementally in temperature from about 1 degree onward, a 1 degree increase onwards. Did you have something to say?
No.
Okay. Now, about these plots, oh, my bad. So one more thing about these plots as well, too, and I think Alex has mentioned this before, is that we are looking for representative sensitivities, right, for each of these regions and these crops that we can convey to stakeholders in some way. And so one way to interpret some of these plots is in the first plot is sort of a proxy, if you will, varying over temperature and rainfall and keeping carbon dioxide constant for climate variability. If we move to the last plot, okay, we're looking at a constant rainfall and just changes in carbon dioxide and temperature, and so that's sort of a proxy for climatic change. And between at least the first and the last plot, we can sort of help contextualize, right, some of the future climate changes and the historical climate variability changes that we're getting in our other analyses, our historical and future analyses. So these are not isolated assessments or analyses. We are hoping that these will inform all the analyses that we do for the historical and the future climate periods. Yeah.
And just as an example, in these cases, the temperature response is immediate and negative for yield. But in some of the examples, I believe Embu, Kenya, and some of the other places that were looked at in the last phase actually had an initial positive response to temperature, which led to a more optimal temperature, a couple degrees warmer, and then yields started to fall off after that point. And if we had had response surfaces such as these, when we did that analysis, we would have understood better why the yields were going up, and also understood the context that that was not a universal condition of warmer temperatures is better. So this type of surface, it might not always look this clean, but it will help us understand what's going on.
Right. And if we can do this now at each, so this was one farm site in South India. If we can do this at one farm site across each of the regional integrated assessments and compare our plots, that could be an interesting type of analysis to do. Okay, so I'll move on to the last few figures in my part of the talk, which are the future climate scenarios and sample analyses here. So here, I wanted to show this new approach that we're using that Alex has reviewed, which is binning or categorizing the CMIP5 results in terms of where they fall in these quadrants, right, which are delineated by the legend that you see above, right? So we've got a hot and wet quadrant in the brown, a cool and wet quadrant in the green, cool and dry in the blue, and a hot and dry in the red. And the definitions, how these quadrants are defined, right, will change upon the GCM response for each site that we have in our assessments, right? The black box is the baseline period. Now, not only is this site variant, but what I'm showing here on the left is the sort of spread of model results for the October, November, December, the Northeast monsoon period. And on the right-hand side is June, July, August, September. So this is the Southwest monsoon period. Both are growing periods in South India. We've been focusing mostly on the left-hand side, October, November, December. But I wanted to show the difference in the spread and uncertainty between the models, looking at different seasonal periods as well, too. Now, sorry, go ahead, Alan.
Yeah, just to quickly mention, we have an R script now
Yeah.
that will produce this. And we will do this at the workshop. So this is one of the reasons it's important to come with a computer that can do R, is that we will make these and we will discuss them at the workshop.
Right. And so I wanted to just quickly show an example first of how we can use the sensitivity experiment, specifically in C3MP, to contextualize these future projected climate changes. And so if you look at this purple box that's been highlighted, we look at a temperature range between the coolest model and the hottest model of somewhere ranging from 1 degree increase to about a 2.6, 2.7 degree increase perhaps, and rainfall changes that go from no change from the current up to about 160% of current values as well too. So if we take those ranges of change and sort of throw them onto the C3MP plots that we'd shown before, and the left-hand plot shows, I didn't have the things there, but it shows precipitation on the y-axis and temperature change on the x-axis. Now this is at a carbon dioxide concentration of 360, but the advantage with C3MP is that we can actually put in a carbon dioxide concentration that's representative of the RCP 8.5 mid-century, which is what we're running, which is about 571 parts per million. But if we look at the boxes, sort of the green arrow on the right and the box on the left, this highlights the range of change that's being projected for this climate scenario by these models, right? And so if we have that 1, if we look at the left-hand side, we have again a 1 to 2.5, 2.6 degree change, which is what we saw over here in June, July, August, September. And the 0 to 60% increase, which actually goes off the chart that we have here. So we can see seasonal changes have some pretty dramatic rainfall increases potentially as well too. And on the right-hand side, you're looking at constant rainfall with increasing carbon dioxide on the y-axis and temperature on the left axis. So this is, again, our climate change proxy. And what we see is that as carbon dioxide temperatures increase, for the range of temperatures that are being projected and further out, we see this tendency to move towards yield declines as well too for irrigated rice. So again, an example of how these C3MP results can be utilized in other types of assessments, future and historical as well.
Yeah, and again, we expect to be able to make these at the workshop and talk with you about each of them.
Right. So each of the plots that I'm showing are plots that by the end of the workshop we should have made for each of the teams. Okay, so just to show this again, because now I want to move on to some of the changes in the future climate period. So just for the sake of example, I'm going to pull out model N in October, November, December that we see here. And I'm going to show you what some of the changed climate parameters look like moving forward. Okay, so I'm going to go through these last 2 slides quite quickly, but I can take questions on this. Here, we wanted to show the number of rainy days. So we've got blue is the baseline, red is the mean change only that we did in phase 1 for Coimbatore, September, October, November, December. And green is the new set of scenarios that we'll be employing, which changes mean and variability as well. And so between the baseline and the mean change only, we see that the number of rainy days each year is pretty much the same. We're not changing that variability at all. But when we introduce the mean and variability change, we do see instances, particularly 1997, right, where we have some substantial increases in the number of rainy days that we see here. Now, we can go in and analyze this and understand this a little bit more. But the last slide that I wanted to show in context with the number of rainy days is the total seasonal rainfall for the Northeast monsoon period, so the same period. And what we're seeing is that what we expect when we took model N is that both the mean change and, of course, the mean and variability change show increases in rainfall, which is also consistent with our historical trends of increased rainfall. What you'll see, though, between the red and the green, the mean change only and the mean and variability change, is some slight differences in the total rainfall, the interannual variability in the total rainfall as well too, although not too dramatic. And this will change, of course, for each site. So we are implementing another layer of complexity here that we need to understand. Okay, so I'm going to turn over to Cheryl in just a minute. I know those last two slides were short. I apologize for that, but I wanted to quickly articulate what Alex has mentioned already. So please come prepared to the workshop. We expect that each team will have the historical data for each site that the crop, livestock, and economic modelers will be investigating, or at least a farm right from each site. If you can quality control and format these a priori, that would be great. If not, we can make time to do this during the workshop, but at least please come with the data in hand. Likewise, we need our climate modelers to come with a computer that has the R programming environment installed along with the MATLAB utilities. So you could see the climate guidebook on how to do this or contact us. Please bring all the R scripts as well too, and we'll circulate any updates and new ones that we have while there or before. And please make sure that you've amended the R scripts to reflect your own paths and directory structure. And finally, we'll need you to download and keep on hand all the climate files as well. So for the GCMs, and Alex has made those available via the Google Drives link that you see below. Please email us if you need the link or where to get these climate files, but we ask that you come with these on your computers as well too.
And that will allow you to run the R scripts. That's
right.
The idea behind that. And if you are coming from a place with a unreliable internet connection and can't manage to do those big downloads, then please send us an email letting us know about that, and we'll try to make sure that we can transfer them to you at the workshop itself.
Right. Okay, so apologies for the short on time, Cheryl, but if you're ready, we can move on to the few comments you wanted to make.
And maybe while I'm transitioning over to Cheryl, if there's any questions for Sonali, please post them. And I worry a little bit because I know the last webinar, we had a different group came over at the very last second at 11 a.m. and took over the call. So I want to make sure I'll get her material out in the next 10 minutes or so. And of course, if there's any questions that we don't get to, send by email. But Cheryl, hopefully you should have received by now the presenter invitation.
Okay, we're getting there. You should be seeing my screen soon. Can you hear me?
Yep.
Okay. And okay, so I've got just a couple slides and then I'm going to go right into a live demo. And not seeing any questions, I will go ahead and proceed. So these are a few useful links if you're going to be using FACEIT, and I'll get into what FACEIT is in a little bit. I see a lot of the people that are connected have already had some experience with FACEIT, either through the crop modeling or part of the FACEIT Help Desk webinar that we did last week. So some of this may be a review for you, but here we've got some sites, the learnfaceit.org site where you can read up on how FACEIT works and how to log in and etc. There are some videos that go through some of our regional integrated assessment workflows that you can look at. And if you want to use FACEIT, the first step is to register at Globus at the www.globus.org, and then request to join the FACEIT group, and then log in using your log in to usefaceit.org using your credentials. Any questions or suggestions for improvement can go to faceit-support at ci.uchicago.edu. And I want to remind people that in Victoria Falls, if you're attending the workshop there, we will have a 4-hour session, Monday, June 29th, on working with FACEIT. This is for the crop modelers, climate modelers, IT people, and really anybody who's interested. And also throughout the week, Allison Brizius from the Computation Institute at the University of Chicago will be available at Victoria Falls for one-on-one help. If you've tried it and you have some questions, try to get together with Allison during the workshop. Okay, so what is FACEIT? It stands for a Framework to Advance Climate, Economic, and Impact Investigations with Information Technology. So just like AgMIP, the I stands for more than one thing. It's an online workflow platform based on the Galaxy framework. It allows researchers to chain together data and applications to allow computationally intensive simulations to be performed relatively quickly using cloud computing services. So these data and workflow can be documented, published, shared, and reused. So we've developed some applications specific to the AgMIP regional integrated assessments, and I'm going to give you a quick walkthrough of what some of those are related to the climate applications. Okay, so up on my screen now you should see, this is the usefaceit.org site. And once you've logged in, this is the first screen you'll see. And over on the left-hand part of the screen, you'll see this is the where all the various tools are, various ways to get data. These are the climate applications that I'll go through in a few minutes quickly. The various models. So right now we've got DSAT and AppSim, and we've got various different configurations of DSAT and AppSim. There's some easy sim tools. Here's the crop modeling regional integrated assessment tools that we've got, and a few more tools, miscellaneous things that we've stuck here under the category of AgMIP. So under climate, what we have, now I want to mention that we're just getting started with climate tools in FACEIT. We've put a lot more effort into the crop modeling workflows. So the CTWN and C3MP tools that Sonali talked quite a bit about in the previous presentation, we are working on tools for those within FACEIT, tools for preparing the simulations, and also tools for analyzing the outputs and running the models. So those are not yet here, but we may, I actually don't think we'll have those at the workshop in Victoria Falls. We are currently working on them, and we will get them up there as soon as possible to help make those kinds of simulations available on FACEIT. So what we have a tool that will allow you to generate the farm site weather. So this one takes input a base AgMIP file or a .AgMIP format file and allows you to enter latitudes and longitudes corresponding to your particular farm sites for the various different AgMIP regions, and it creates these different farm site .AgMIP files. There's an app here that will allow you to take your baseline climate files, and you can select your GCMs of interest. Here I'm just selecting the EIKOR files that were used in phase 1. And you can select your particular scenario, 8.5, mid-century, let's say, and then whether or not you use the simple delta method or the mean and variation. And I'm not actually running these. Well, I'll show you some results in a minute for some pre-run. Since we're kind of running out of time here, I'll do this rather quickly. We've got an app here that will produce metrics for your .AgMIP file, so you can look at a given time period and a particular variable, whether you have an average, maximum, or so on. Oops. Not sure what happened there, but at any rate, I don't have any climate files to enter into my history, so that's giving me a little error there. And then here we have a plot climate scenarios anomaly. So this will compare baseline to future climate scenarios for the variables of your choice. So you can run through quickly some analyses there, and it produces some graphics. So very quickly, I'm going to go to a published page. So Wei Zhang, who's been working on implementing these R scripts, these are the same R scripts that you use on your desktop computers. He's taken those and created apps within FACEIT. So he's pre-published a few of these. Here is some data that he entered using a particular .agmip file. Here's a workflow that he created. I can import that workflow and start using it. And it basically looks like this, where first we generate the farm site's weather, then we generate the future climate scenarios, and then we add the app that plots the climate scenarios anomalies, such that you can automate this process and plug different data points in at the front end and get the plots back at the end of the workflow. So I'm going to go back to the published pages, and let's take a look at some of the results. So this is one that had already been run for, I believe it's, I don't remember what the site is, but I'm going to look at the final results. And this was, this is a result of the plot climate anomaly workflow that we just looked at, where we've got a change in, this is a relative change in maximum temperature. We've got, I believe he used 5 climate scenarios. Oh, I see. Here they are. Three different climate scenarios, or 3 different GCMs, each with the same climate scenario. The red line is the mean of these, and all of this is an offset from the baseline. Okay, so that's one type of output you could get from that plot climate scenarios.
Just to clarify, Cheryl, the spread there is across farms, correct?
The spread here is across farms and also across the GCMs.
Yeah.
Yep. So that, in a nutshell, we're already at the top of the hour, so I really don't have much more time, or really any more time, to go into additional detail. But just a plug, you will have the opportunity to use this. I encourage you to try it before you get to the workshop, so that you can have questions and be a little bit familiar and more productive when we get there.
Great, thanks, Cheryl. And I'll just add my own 2 cents here, which is the you know, what we're really doing here, and what we hope that the people on this phone call will be able to do is, you know, understand this whole approach, be able to do it mechanistically using the R scripts and things like it, and then once they're comfortable with it, being able to use a tool like FACEIT to dramatically increase the number of models, the number of sites, the number of analyses and metrics and everything that you can explore. So it's basically, we're learning how the tools work, and then getting better and better access to high-powered kind of information from them. So with that, we're at the end of our presentations here. I know we've thrown a lot of information at you, but what really the bottom line is, we are very excited to see many old faces, old friends at Victoria Falls, meet some new ones. Please bring your data and a computer you can work on, so that we can actually have true work sessions. And what we really want to do is, we feel that in phase 2 we can get to the analysis much more quickly, and that what we don't want is just a session where we say we made our scenario, we're done. We want to look through it, understand it, get to that higher level analysis that will produce more papers, will better engage the stakeholders, and provide more confidence in the results going forward. So I'm going to be quiet now. Any questions? Looks like we haven't been kicked off. That's a good thing. But if there are any questions, let us know, either on chat or just speak up. And if not, if this was just a lot of information and you need some more time to digest, hopefully it just means everything is clear, but my experience, that's rarely the case. please, feel free to look through this again, check out the protocol, the guidebook, send us any questions by email. I think Olivier is on, and I'm gonna pick your questions from last time. So actually, Sonali, I'm gonna make you presenter one more time. Could you pull up that let's see, it's the slide that had the spread of GCMs, how we picked our 5.
Mm-hmm.
So Olivier asked some questions in an email following the last one, and I wanted to make sure we addressed them on this time. I don't know if Olivier is even still on, but we'll use that as an example in case other people had the same questions. So what Sonali is pulling up is the 5, our kind of selection of 5 GCMs. And if you remember, this was where we had our quadrants, our hot and wet, cool and dry, etc. And this is a fairly new approach. We can see your screen. This is a fairly new approach, so let's take a couple seconds to look at this some more. Show mode. Good. Okay, so let's just leave it there. So there are a couple things that are clearly decisions that we've made, and that's why it's a good time to ask questions. And the short of it is, this is an approach that we're recommending. I don't think it's ironclad, and we are very eager for your own feedback and creativity on this. So let's take some examples on this. The first decision we made was to center the quadrants on the cloud rather than on the baseline. So rather than having the dashes that go across, the precipitate, or that go across all temperatures, signifying where it's wet and dry, rather than having that go over the current period rainfall amounts, we have it on the center of the cloud. So you can see on the left, this causes some interesting examples. Because the cloud in this monsoon region is strongly towards wetter conditions. First of all, that's interesting information for stakeholders. But what it means is that even our dry models are either the same or not much different than current conditions. So it's not actually drier than present. It's just dry compared to the overall cloud. So that's going to be important context as we're doing that. In other cases, it will be closer to the current period. I would say on average across the whole world, there's pretty strong uncertainty in both directions. And certainly that makes sense if you flip it to the other dimension. If we centered cold and wet on current, then everything would just be, if cold and warm on current period, everything would be warm. The other question that Olivier brought up was the central box. How did we choose the size of that box? And the answer to that is, if you take the standard deviation across all of the GCM's temperature, and you take the standard deviation across all of the model's rainfall, and then what we ended up doing was taking a half of that standard deviation in each direction. That formed the central box. Now, if we assume that this is a normal Gaussian distribution, that central half standard deviation each direction covers about 40% of results. So this does a pretty good job. It's a little bit potentially over-representative, as you see on the right. It looks like about 35% of the models on the right fall into this middle quadrant. And since we have 5 different regions, that's over-representative, but that's probably okay. We experimented with 1 standard deviation and smaller than half, and for the most part, we felt pretty good about this. We were aiming for something about a fifth that covered, the center part of the distribution. So that's the answer to that. The other question is, what happens in the cases where there is an empty quadrant, or maybe even 1 model in a quadrant? And there, we definitely agree that can cause some interesting questions. We might also have cases where there are very strong clusters of models that don't necessarily fall under these, defined divisions. So in those cases, what I would ask for is to see a plot and have somebody justify the selection of a different subset. I'm perfectly happy to be convinced on that. There may also be cases where we have, clusters of hot and wet, hot and dry, and maybe hot and neutral conditions that might want to be explored. I think that the information that came from the crop and the economist is that they probably could not take 6 models. So we don't want to end up with, too many clusters. And I would also argue against chasing the more extreme model like this G model on the left, which is very wet. I wouldn't want to make that its own cluster and emphasize that too strongly personally. But in the end, what you see in this plot are the various quadrants, and the dots that you see are the center of all of the models that fall into those divisions, into those quadrants. That dot is potentially a guiding mechanism in terms of selecting a representative model from each region, but it becomes up to you which one you actually use, and I would hope that we could justify that. In this case, it's just using the one on the left as an example. It ends up being pretty easy to look at. Looks like we have the S model in the cool and wet. I would suggest the N model for the hot and wet, the A model for the hot and dry, and then I can't quite see what that one is, but it's the E model. Looks to be right near the blue, the light blue dot. And then in the center, it looks like we have two models that are almost the same, so take your pick on those. So that's the idea there, but of course, if you're willing to justify it, we can be more creative and come to a better solution for you. Now, did I miss any of Olivier's questions, or Olivier, did I answer some? It looks like he's heard me, so that's good. Let's see. So Sonali, we're seeing what you're doing here. So we were looking at Olivier's questions there. Yeah, and what's interesting also, we realized when we were making this plot left and right here that the N model falls under the hot and wet condition for the northeast monsoon, and the same N model is recommended as the hot and dry condition for the summer monsoon. So that's an interesting thing that seems to fall out.
The other thing that I think Olivier had mentioned that I think Alex just briefly talked about, but maybe you want to just talk about it a bit more. So if there are no models that fall in one quadrant, you might potentially have clusters of models in other quadrants with which you might want to select from. But I think Olivier had also brought up the idea of perhaps instead of using the width of the box as we've defined it as one standard deviation and then grouping the models according to these quadrants, that maybe there's an overall clustering of models to look at. And I think, Alex, you had mentioned that if that is something that people want to experiment with, we would encourage even a different approach to doing this. We're happy to have a dialogue about that if the quadrant method for some reason isn't representing your sites or the GCM response as well as you'd hope that it would be.
But maybe this is a good time to underscore why we're doing this,
right.
Which is the idea here is we have 20 GCMs or more once we process the later GCMs that have come out since phase one. Once we have all those GCMs and we know that we can't run them all, we have to select a subset. So this is our attempt to come up with a subset that we can assign representativeness and weights on, such that we can pass the information down the chain of the AgMIP regional integrated assessment. So even if you create clusters, I would encourage you to come up with shorthand of what they are. So maybe this is the very hot and wet cluster, or the
how did you do
how did you do it? So, but something that allows you to speak about it in your write-ups and in your documents for stakeholders beyond just cluster 4. So if we can represent those models in a way that is logical, that makes sense. The other thing, of course, we have to be careful of is the temptation to just jump into the middle here. The average group will look at this and say, let's just take that black model in the middle. It represents the entire cluster. Our point in AgMIP, in not just this project, but across all projects, is not to use an ensemble to focus just on the central solution. The ensemble tells us the spread and also things like the ensemble median, and we have to recognize the incredible value in both of those pieces of information. If you think of it from a stakeholder's perspective, we do not want to give a false sense of security that there is a prediction happening here. We want to understand the risk that any of these equally plausible results, in our opinion, need to be recognized and potentially planned for. All right, so Olivier asked a question about, is 5 models a hard number, or could there be 4, for instance? Certainly it's possible that there would be no model in a quadrant. I'm guessing the economists wouldn't have a problem doing less models. So maybe we could think about that. I personally believe that in the climate literature, you start to get some eyebrows raised if you only have a subset of 4 models. I know it's not that incredibly different, but that's that's the concern that would be nagging at me. Is, you know, if everything in this project is geared up for 5 models, strikes me that if there was nothing in one quadrant, then there probably is more variation in another quadrant that we'd want to represent. All right. Any other questions? All right. Well, we've already kept people past time. Thanks to Sonali and Cheryl for their work and their presentations. This has all been recorded, so you can pass on the link to friends or people who didn't make this call, or if there's a point you wanted to share with the PI of your project, please do share. We're always available by email, and we look forward to working with you in the weeks up to the workshop, and then especially at the workshop.